So, thank all of you guys for having me here. Such a pleasure to be presenting this topic. I'm not that rusty programmer, so I kind of bring it a little bit more to the front-end side. So probably what we're gonna see here is more like about what I do on a daily basis. So with no further ado, I will talk about WebAssembly with Rust. And first of all, just introduce myself a little bit. So my name is Raphael Marques. I work here at the MBIO for almost 2 years as a front-end engineer at Sela Center, which is an internal team that we have. I'm 29 years old, I'm from Brazil, and I'm just living here. 2 ways to contact me. The first one is my LinkedIn, and the second one is my email, my personal email. So if you want to contact me, just like send a message, my email, something, I'll definitely answer you. I'm not promising that I'll do it fast, but yeah, I'll answer you somehow. So let's jump into a more technical topic. And we're gonna start with a more generic question like, what is WebAssembly? Because we're gonna talk about it, I guess it's important to bring some common knowledge about it. So what is WebAssembly? And we're gonna see this like change of wasn't in the presentation, so it means the same. It is the like short way to say WebAssembly. We're gonna find it a lot of times in documentation and so on. So WebAssembly is a binary instruction format that enables high-performance execution on browsers, on web browsers. It's designed as a portable target for the compilation of high-level language like C, C++, and of course Rust, which is the one that I will be presenting today. But definitely we have a lot of other supported language here that we can compile to WebAssembly, targeting WebAssembly. But this is the most famous one that we already have like some good support. So we do know a little bit of what is WebAssembly and what is its goals like. So I just brought 4 of the goals here, which is basically defined by the WebAssembly. The first one is be fast, efficient, and portable. So WebAssembly code can be executed at near native speed across different platforms by taking advantage of common hardware capabilities. The second one is be readable and debuggable. So WebAssembly is a low-level assembly language. However, it does have a human-readable text format that allows code to be written, viewed, and debugged by hand. So the main goal of WebAssembly is to try to make it like faster compilation, faster performance, and this is one of the reasons why it is faster, because we do have this WebAssembly in low level, so it means that the machine will not need like to translate this code to a machine level. It will be closer to the machine level, so it will be faster. We're gonna talk, I will talk a little bit more about performance in future slides, so it's just like an introduction about it. The third one is keep secure. WebAssembly is specified to be run in a safe sandbox execution environment, like other web code, and it will enforce the browser's same origin and permission policies, like we have with JavaScript and everything that we are using right now in web browsers. And the last one is don't break the web. So WebAssembly is designed to play nicely with other web technologies and maintain backward compatibility. I guess this is one of the most important things in the WebAssembly, because when we talk about developing a new feature or a new thing or using new technologies, it's kind of a deal breaker when we have like to learn and to go through this new technology and change everything that we have to this new one. So with this backward compatibility, it just means that we can write WebAssembly and integrate this code into our JavaScript application. So this is one of the strongest points here with the WebAssembly. So right now we already know a little bit of what is WebAssembly, what is its goals. So the question is why we should consider to go to WebAssembly. So the first reason that I brought here is interoperability, which is basically related to the thing that I just talked right now about backward compatibility, yeah. So interoperability basically is that WebAssembly was released, and the goal of this release was not like to substitute the JavaScript. It was like to work with the JavaScript. So you don't need to choose like between one or another. You can use both together in the same like application, and you can just use like the best part of each one. So this is a good point about it. The second part is language diversity. And it brings a little bit of a tricky good point, because it brings a lot of cons also, especially when we talk about language diversity, we think like in a magic word where we're gonna select like different languages and bring only the good part about this language, where we're gonna have like the best part, I don't know, about C, about C++, C#, and so on, and Rust. And then it will be like magic. We'll have like the most performatic code ever, and that would be magic. That would be awesome. But on the other side, we have the reality where we need developers to know all of those languages, and we need to think about that when we decide to go through this technology and through this way of doing, because we can create silos between our teams. We can create like some problems there. We need to do this kind of trade-off, thinking about like if it is or not the best decision that we need to go. And we need like to decide if it's good or bad for us. And the last one is performance. Performance is one of the things that we most talk about when we talk about JavaScript and web browsers, because JavaScript is such a language that brings like a lot of facility for us, especially for developers. So the cost of it, I guess, is performance. But when we talk about performance, why was WebAssembly so much faster than JavaScript? So just brought here 6 of these reasons why WebAssembly is faster than JavaScript. The first one is fetching. So fetching WebAssembly takes less time because it's more compact than JavaScript, even when compressed. Basically, what I'm saying here is the code that we're gonna have in WebAssembly compiled will be a binary code. So it will always be like smaller, and will always take less time to fetch this code to the browser, to wherever you're running your code. So especially in slow connection. So this is one of the things that we should take in consideration because it will be so much faster. The second one is decoding. So decoding WebAssembly takes less time than parsing JavaScript. The third one is compiling. So compiling and optimizing takes less time because WebAssembly is closer to the machine code than JavaScript and already has gone through the optimization and on the server side. So what it means is that when we compile our code, when we build our code in JavaScript, we are building it, then the browser gets this code, transform this code into a binary code, but it takes time. So the bytecode, but it takes time because it is like a whole process to go through. When we write this code in WebAssembly or another language aiming the WebAssembly, it means that we are compiling this code to a binary code where we'll be closer to the machine code. It means that this layer between the machine and the code that you've just written will be closer, meaning that will be faster. Reoptimization. Reoptimization doesn't need to happen because WebAssembly has types and other information built in. So the JavaScript engine doesn't need to speculate when optimized the way it does with JavaScript. So in JavaScript, we have this strategy called reoptimization. Basically, it assumes some behavior on your code where based on your functions, based on the compiling and the optimization process, it try to pretend and try to see, try to imagine how your code will behave, and then they try to optimize it, but then you need to run it every time to check if your this prediction were right or not. So if it were not right, it will run again, so it is the reoptimization process, and in WebAssembly you do not have it because it's already like compiled and optimized like from the first time. The fifth one is execution. Execution often takes less time because there are fewer compiled tricks. WebAssembly set of structures is ideal for machines. So here, when we are developing code in JavaScript, especially when we're developing like for humans, we are developing it to be human readable. And when we compile this code, when we do this strategy, thinking about the developer experience, for the compile, for the bundle time, is sometimes the compiler do not understand it very well and takes a little bit more time to compile it in the most optimistic way. So it takes more time to execute the code. On the other hand, with the WebAssembly, as it is already like a binary target language, it is compiled. Thinking about that, it is like made for this optimization to be done like in execution, so you don't need to think about that. And the last one, garbage collector. The garbage collection is not required since the memory is managed manually. So in WebAssembly, we do not have the garbage collector, and JavaScript do have. So it kind of creates this unpredictable behavior on the JavaScript because we don't know when this garbage collection will be run or not. So there's some schedules already in the web browser and JavaScript engines where it tries to optimize this time to garbage collect, but sometimes it happens like where you shouldn't, like you're running like a high cost function and you run the garbage collector, so stop running your function, so it kind of, it's unpredictable. So it's harder for us to think about how your code will run, how it will be executed. So this is 6 reasons why the WebAssembly is faster than JavaScript. So right now we have these reasons, and so we can jump into the Rust with the WebAssembly. So as Miguel already mentioned, we can compile the Rust code focusing and aiming the WebAssembly. And here's one of the reasons why you should take in consideration going with Rust when we talk about compiling code to WebAssembly. There's one reason that I didn't brought here, which is that Rust was one of the earliest adopters of WebAssembly. So the community kind of started programming and started developing a lot of tools for it. So it makes like a lot of lessons learned, a lot of process that the other languages still not reach there. So it's a good point. The performance is obviously one point. So Rust is known for its low-level control and zero-cost abstractions, making it ideal to high-performance applications. The safety, the Rust ownership system eliminates many common bugs, providing a safe alternative for web development. So this here is one of the most important things. We're not like putting another technology to introduce bugs here. So with the safety and ownership system that they have, it kind of reduces the risk of it. Of course, there's a risk because in real world, there's a lot of possibilities, but it just reduces it. Interoperability, so Rust can seamlessly interface with JavaScript, allowing for easy integration with existing web applications. I'll show a code here, and you will see this interoperability between the Rust and the JavaScript. Community support, activity community, documentation, and learning process. So this is a very important thing that sometimes we just oversee it because we don't take a lot of consideration into it. But at the end of the day, in the daily basis, the developer experience changes a lot by the community support. So when we have like this active community, documentation, the learning process. So if you go to the Rust documentation, it's like very well written. They change a lot, they are releasing a lot. So it means like that it's something that we need to take into consideration when we are choosing a language to go on. And the tooling, there's Cargo that Miguel already presented. That's the WASM bindgen, which is the one that will create this interoperability between the JavaScript and the Rust. And the WASM pack, which is basically a crate. They call like libraries crates. So it is a crate that will be responsible to compile this code in Rust to WebAssembly. Then it will be available in JavaScript. Then we can use this code and integrate this whole thing. So code time. I just brought a simple example here. This is just like an example from scratch to integrate your code with your JavaScript application. So it's very straightforward and a very simple one. This first command here is just to install Rust into your machine if you haven't done it before. Then we're gonna start install the WASM pack, which is the one that I just mentioned before, will be responsible to compile this code to the WebAssembly, to your Rust code to WebAssembly and then to JavaScript. Then it will be available for us. After that, we can create the project. So we just run this command here, cargo new lib, which will be a lib, and then the name of your project. I was very creative and just would require a Lex example. Then we're gonna start writing Rust code. As you can see, my Rust ability is not that good, so I just write this simple one here. But this is a very basic code which basically import the WASM bindgen crate, the one responsible to do this interoperability between the JavaScript or whatever code you are running. So basically we here are going through, I don't know if I can point it. Well, let me try to use the mouse because, okay. So basically this first line here, we are importing this library like in JavaScript. We import the library and the functions that we want. So we are importing this preload and then everything from it. We have this notation here, which is basically telling the code that everything under this declaration here of the WASM bindgen will be like something that will have this interoperability. So we're telling the code that we're gonna have an external function called alert that will receive an S, which is a string. Basically, we're just using the alert from the JavaScript. Then we declare it again, and then we're going to declare a public function called add. That basically will receive two numbers and return a number. But in the middle of this function, we're going to use this alert that we just declare here and call from the JavaScript. So basically, we're just declaring this variable here called result, which is a number that will be the result of the sum from A plus B. And then in the alert, we're just going to format it using this macro here that is from Rust, concatenating this result string with the result of the sum here. And then we're going to use the alert. So from the ones who is comfortable with JavaScript, know that in the browser, it will pop up a box with the result the string and then the result of the sum. And we're going to return the value of this result. So after that, very straightforward. We're just going to run the command was_unpack build targeting the web. We can target this code for a lot of other platforms. So as we're going to use it on the web, we just target the web. And then we're going to have a structure like this. So as I mentioned, it's a very simple example here that we have, where basically we're going to have this structure here from source to cargo, TOML, which is the one that have been created by the first command that we run. And then when we run the build, we're gonna have this package here with this whole structure, which basically have the JavaScript code, the WebAssembly, and the integration between the WebAssembly and JavaScript using the WebAssembly API that we have in JavaScript. So after that, I just create a simple file here, index.html, and this is the file that have the simple structure that will be responsible to integrate the code that we just built with the was_unpack, and we're going to integrate it here with our JavaScript. So we start using Rust, build it through the WebAssembly, and right now we're just integrated with JavaScript. So very simple, very straightforward. We're just going to import these two functions here. The first one is init, which is the one that will kind of instantiate the instance of the WebAssembly API. And then after that, we'll be able to use all the functions that we just developed there. So here's the add function that we just create. And then I just create this function here with the sync function called run that will instantiate the WebAssembly API, and then gonna call the function add, passing 21 plus 21 as parameter, and then this constant result here will just be declaring we receive the result of this addition here. I'm not doing anything with this result. I guess I should console log it, but as we have the alert, I didn't need to have like a console log to show the result of this function here. And then at the end, I just call the function. So as a result, we do have here, and that's it. I guess that's it. So the main goal here was like to create and to show that it's not that difficult to go from one language to another one using the WebAssembly. In this case, I use the Rust because it's the integration with WebAssembly, as I mentioned before, is more like well documented. I guess it's more advanced than the other ones, and we can use this as a new tool to our toolbox. It doesn't mean like we need to change the whole code and we need to go through this new technology and go like crazy about it. It's just like a new possibility for us to bring, especially when we have like high cost applications, like something that run the browser, for example, Figma that we use a lot. It use the WebAssembly. This is one of their strategy. They use like React in the front end as the front end framework, and then and then they use the WebAssembly to run the most performatic tasks. So I guess that's a wrap for the application. Thank you, guys. And right now, QA time.
Thank you very much. Google Earth is also a really good example with the WebAssembly.
Google Earth.
Yeah.
I guess right now they changed the AutoCAD also, which is like a 30 years old application. They just converted to the web right now. So
everything can run on the web now. Browsers is the future.
Bro.
So, questions?
Hello. So I saw that a package.json was created when you compiled. Can you use that to like publish the package to a register and then import that from like npm, or do you need like all the WASM code and Or can you actually?
No. Actually, in the real scenario, you're gonna probably need to publish this this package and then publish into the npm, and then you're gonna need to install it and then use like we use like some other external libraries. But yeah, you're gonna need the WASM, of course, but it needs to be published to be used like externally.
But is the browser the one that is going to be handling the WASM file in this case?
Yeah. Because in the JavaScript engine running the browser, which browser you select will be the responsible to convert it.
Thanks.
I imagine that the .ts was the types file, so that you can, nice.
If you use TypeScript, you'll like.
Yeah, very nice. Any other questions?
Sorry, guys. Few questions, but yes, it will be interesting for everyone. Could you back to the Rust code, please? That result, this is only for the logger?
Yeah, this result is just because I returned the value, but I didn't use it. Like I just actually use it here on the cost result, but I didn't use it on the JavaScript. Just for the sake, if I want to use this result, it will be returned from the function.
The doubt is probably around the syntax of Rust. If you put the variable at the end, it basically returns the.
Okay. The question is. I tried to do some tests a few months ago, and I had a lot of issues when I'm using a type of variable or a variable on JavaScript, and everyone knows JavaScript is a wide world. But here, when you pass a type, how do you can manage which type you will pass correctly? Because sometimes, if you are using TypeScript, TypeScript will alert or
Like the type is different from the one that you declare.
yes.
Yeah. So in this case, in this file here, we're gonna have the types. So if you are using the TypeScript, it will like show as any other TypeScript application. If it's in JavaScript, it will happen like in the JavaScript. It will have an error in the runtime.
Okay. Just one more. Sorry. This is easy to integrate with the most famous frameworks, like, okay, I can just import my, I don't know, sort functions on my React page.
And that was the goal here, like to use vanilla JavaScript, because as I use it here, you can use it like in any other framework, like Angular, Vue, React, or any other like technologies that you're using with JavaScript or TypeScript. So
you should create the build considering this, right? Yeah, because
framework I'm gonna use at the end? No, because at the end of the day, it's JavaScript. So whatever framework or lib that you're using, if it is in JavaScript, you don't need to think about it. The only concern that you have is target web. When we target the web, we're gonna render this code, we're gonna compile this code to JavaScript, and then it will be available for you to use in any of these frameworks or libraries that you want to use on the JavaScript side.
so put in the protocol. Okay, thank you. Great presentation.
Thank you. Any other questions? Okay. Thank you very much, Raphael.